Welcome to the debate. If you're listening right now, I want you to imagine you are a top-tier football coach. You spent your entire life studying the game, agonizing over every single tactical nuance.
Right, sweating every little detail.
Exactly. Now imagine an algorithm looks at your meticulously crafted playbook, redraws it, and when put to a blind test, domain experts from a club like Liverpool FC actually prefer the machine's tactics over yours a staggering 90% of the time.
It's wild to think about, but I mean, that isn't just a hypothetical scenario anymore, is it?
No, it is exactly what happened with the recent development of tactic AI. Today, we're looking at the profound impact of artificial intelligence on high-level football tactical planning.
And the fundamental question we really have to grapple with here is, well, will AI's rapidly advancing predictive capabilities eventually replace human coaches in tactical planning?
Right, or does the fundamentally unpredictable, chaotic nature of physical sports dictate that AI must strictly remain a collaborative tool? You know, something that only enhances human judgment rather than overriding it entirely.
Based on the collaborative architecture of tactic AI, I'll be contending that the chaotic, dynamic variables of a real-world pitch guarantee AI will only ever serve as an assistant.
And I'll be arguing that AI's mathematically superior tactical models signal an inevitable future where algorithms supersede human tactical design completely. We've crossed a threshold where intuition simply cannot compete with calculation.
I suppose we should jump right into this then.
Let's do it. Look, when we analyze modern professional football, the margins between winning and losing are, well, they are microscopically tight.
Absolutely. Top-tier clubs employ absolute armies of coaches, video analysts, and data scientists just to squeeze out a fraction of a percent of an advantage.
Right. But the reality is that human cognitive capacity has a hard biological ceiling when it comes to processing spatial data. We can only track so many moving bodies at once.
Sure, the brain has its limits.
Exactly. So I look at tactic AI, and I don't just see a neat new software program. I see a total paradigm shift. We're moving away from relying on flawed human observation and shifting toward modeling player relationships as mathematical graphs.
Which is a massive leap forward for data analysis, I'll grant you that.
It is, and the evidence from the Liverpool FC collaboration is the smoking gun here. In qualitative blind studies with their domain experts, tactic AI's suggested player setups were favored over existing human design tactics 90% of the time.
It's a huge number.
It's an overwhelming majority. It proves that when the machine is tasked with optimizing a tactical setup, it is demonstrably superior. It doesn't just assist the human architect, it replaces the flawed human blueprint with a flawless mathematical one.
I come at it from a completely different way, though. I look at that exact same 90% figure, and I see a brilliant but highly specific collaborative tool that is tightly bounded by the physical realities of the sport.
Bounded how exactly?
Well, we really have to look closely at what tactic AI is actually analyzing to understand its limits. It focuses almost exclusively on set pieces, specifically corner kicks.
Which are a crucial part of the game.
They are, but why corner kicks specifically? Because the execution of tactical plans in open play is incredibly messy. I mean, open play involves unquantifiable factors.
Like what?
Think about player fitness.
In the farthest reaches of space, one scientist refused to stop searching. Every discovery uncovers The Scientist Explorers. Available now, just $4.99 on Amazon Kindle Unlimited. Start the adventure today.
Player fitness, sudden surges of lactic acid, the state of the pitch deteriorating in the rain, or even the unpredictable emotional reaction of the opposing team after a bad call.
Sure, those are variables.
Right, but corner kicks, on the other hand, are isolated. They happen from a fixed, rigid position. It's a brief interruption in play that allows for a controlled, pre-agreed pattern to unfold.
And the AI masters those patterns.
It excels in these brief, controlled interruptions because they resemble a closed system. But the actual sport is incredibly fluid. A machine can draw the perfect tactical map, but the territory itself is physical, biological, and unpredictable.
So you're saying it's just a tool?
Exactly. Therefore, the AI acts as a collaborative tool that strictly requires a human coach to navigate those unquantifiable human realities.
I want to focus on that 90% preference rate because dismissing it as just a controlled interruption, I think drastically underplays its significance.
I wouldn't say I'm dismissing it.
I see why you think that, but let me give you a different perspective. That 90% preference rate for the machine's recommendations is a watershed moment, and it perfectly mirrors the evolution of chess engines.
Oh, like AlphaZero?
Yes, exactly like AlphaZero. When those programs first emerged, traditionalists argued the exact same thing. They said the computer could only win in highly structured, specific endgame scenarios where the board was simplified.
Right, the closed system argument.
Right, but eventually, the engine's ability to perfectly calculate millions of variables didn't just help grandmasters. It completely replaced human opening move theory. No grandmaster today relies solely on human intuition because the math is simply better.
That's a compelling argument, but have you considered the fundamental flaw in the chess analogy?
I don't think there is a fundamental flaw.
Well, you're equating a completely closed system with an open, dynamic environment. On a chessboard, the bishop isn't going to pull a hamstring halfway across the board.
Fair enough.
The rook doesn't have to deal with a waterlogged square. I mean, chess has 0 biological variables. A corner kick happens, maybe 10 times a match on average?
Roughly 10 times, yes.
Right. So 10 times a match, the game stops. The ball is placed on a fixed spot, the players have a moment to catch their breath, get into position, and execute a set routine.
It momentarily becomes a closed system.
Exactly. For those few seconds, yes, football momentarily resembles chess, and it is genuinely impressive that an AI can dominate that specific, rigid scenario.
But you don't think it scales up?
No. Because trying to extrapolate a 90% success rate from a static, controlled set piece and project it onto the other 89 minutes of continuous, unbroken play ignore the inherent limitations of the technology.
I have to disagree there.
You can't take a model trained for a dead ball situation and assume it naturally maps onto a full-speed counterattack. The open pitch isn't a clean graph. It is a collision of messy variables.
I hear you. But the idea that an open pitch isn't a graph is exactly where our perspectives diverge. Mathematically speaking, it absolutely is a graph.
A graph? How so?
If you're listening and trying to visualize this, don't think of a graph like a bar chart. Think of it like a constellation of stars. In graph machine learning, every single player on the pitch is a dot or a node.
Okay, I follow you.
The relationships between those players, the distances, the passing lanes, the closing speeds, those are the connecting lines or edges. As the players move, those invisible edges stretch, contract, and shift in real time.
Right, tracking the spatial dynamics.
Exactly. For a human coach, trying to track 22 moving nodes and the hundreds of shifting edges connecting them is just impossible. But for an AI, mapping that web is trivial.
Sure, computers are great at tracking moving dots.
But the limitation historically hasn't been that the sport is too messy or biological. The limitation has simply been data efficiency. And that brings us to how Tactic AI actually processes this spatial data, using a concept called geometric deep learning.
Which is how it handles the symmetries of the pitch, right?
Precisely. Let's break down why that is so revolutionary. In football, high-quality tracking data, the incredibly granular camera data that tracks every player's coordinates 10 times a second, is actually quite scarce.
Yeah, you only have a few hundred matches played each year in a given league.
Right. So if a human coach watches film and spots a brilliant tactical exploit on the left side of the pitch and they want to apply it to the right side, they have to do an enormous amount of mental gymnastics.
Because the angles change.
Exactly. They have to conceptually flip the entire scenario in their head, accounting for the fact that a left-footed player is now on the right side. The angles to the goal have mirrored. Everything changes.
And Tactic AI skips that step.
Tactic AI uses geometric deep learning to solve this instantly. It explicitly produces player representations that respect the mathematical symmetries of the football pitch.
Meaning it treats the left and right sides of the pitch as reflections of each other.
Exactly. It automatically understands that under a horizontal or vertical reflection of the pitch state, the core tactical situation is fundamentally equivalent.
So it doesn't need to see the play happen on both sides.
Right. It doesn't have to learn this symmetry from scratch by watching thousands of hours of right-sided attacks. The mirror effect is baked directly into the architecture.
It just multiplies the usable data.
Yes, it essentially quadruples the usable training data without needing new matches.
A human simply cannot perfectly mirror complex, multiplayer geometries in real time. The algorithm does it natively.
Look, I will absolutely concede the brilliance of geometric deep learning from a mathematical standpoint.
It's undeniably elegant.
It is. The ability to automatically compute identical player representations under horizontal or vertical reflections is a masterstroke for solving the data scarcity problem. But I'm sorry, I just don't buy that this eliminates the need for human intuition.
Why not? The math is perfect.
Let me explain why. Mathematical symmetry simply does not exist in human biology.
But the dimensions of the pitch are perfectly symmetrical. The physics of the ball are symmetrical.
The environment is symmetrical, yes, but the human beings operating inside it are not.
I don't see how that breaks the model.
Well, an algorithm can perfectly reflect a pitch layout from left to right, but it can't symmetrically reflect player fatigue. It can't symmetrically reflect a sudden downpour on one half of the pitch that makes the grass slick.
But it's calculating the optimal spatial arrangement.
Let's ground this in reality. Imagine Tactic AI generates the mathematically optimal corner kick routine using this beautiful geometric deep learning. It analyzes the nodes and edges, and it tells your center back to make a high-velocity run to the near post.
And statistically, that run creates a goal.
Mathematically, it's flawless. But what if that specific center back has been battling a slight calf strain for the last 20 minutes? What if the opposing defender marking him is notoriously aggressive when frustrated?
Those are edge cases.
They aren't edge cases, they are the game. That psychological variable simply isn't in the spatial tracking data. The math always assumes a vacuum. It assumes the nodes operate exactly as they did in the training data.
So you think the coach is still required to translate it?
Absolutely. The coach's subjective understanding of their player's current physical and psychological state is the mandatory filter for any AI output. The symmetry you're talking about is a mathematical illusion the moment the referee blows the whistle.
I'm not entirely convinced by that line of reasoning, mostly because it assumes the AI is forever blind to those biological variables.
For now, it is.
But we are already moving into an era where player load, real-time biometrics, and fatigue levels are being quantified and fed into these systems. But let's table the future and focus strictly on what the system is currently doing, because it gets right to the core of our disagreement.
Over whether this is collaboration or replacement.
Exactly. You keep using the word filter, which implies the coach is still the master architect of the tactic. Let's actually look at the predictive and generative capabilities of Tactic AI.
Okay, let's look at them.
From these complex graph representations, the system can accurately predict which specific player is most likely to make first contact with the ball. It can predict the overall probability that a shot will even take place.
Based on historical data.
Right, and furthermore, it acts as a highly sophisticated retrieval system. If a coach is facing a specific defensive setup, the AI searches its latent space, which is essentially a massive, multi-dimensional landscape of patterns that a human brain can't even visualize, and retrieves historically similar corner kicks to show what worked and what didn't.
It finds the patterns we miss.
Yes. If the machine is telling you exactly who will touch the ball and calculating the exact percentage of a shot occurring based on data a human can't process, the human is no longer designing the tactic.
But you have to look at how the creators of Tactic AI explicitly frame its function.
How so?
They built a generative recommendation system, an assistant. Let's look at the generative component you just mentioned. It allows coaches to, and I'm quoting the concept here, sample and explore alternative player setups.
Right, generating new tactics.
Generating options. The software suggests slight adjustments to player positions or starting velocities to either maximize or minimize the estimated shot probability. The key action there is sampling and exploring.
Exploring the optimal path.
It provides a palette of options. The human coach collaborates with the tool. They look at the suggested adjustments on an iPad and then rely on their decades of experiential judgment to select the specific routine that best fits the human realities of their squad that particular day.
I wouldn't call that collaboration.
That is the very definition of collaboration. The AI is a tool generating options. The coach is the executive making the final decision.
I see the appeal of framing it that way, but let me push back on this idea of the coach as the executive decision maker in this dynamic.
Go ahead.
Think of it like this.
If an architectural software tells a structural engineer, if you build the bridge's support columns at this exact angle, it has a 90% higher chance of surviving a massive earthquake, the engineer doesn't collaborate with the software.
I see where you're going.
They don't sample and explore for fun. The engineer follows the math, because deliberately ignoring a mathematically proven optimization would be professional malpractice.
But a bridge isn't a football team.
It's the same on the pitch. When tactic AI suggests a 1-meter adjustment to a player's starting position that mathematically maximizes the shot probability, and domain experts already agree the machine's tactics are superior 90% of the time, well, the coach's judgment is largely an illusion.
An illusion? That's quite a claim.
They are effectively reduced to a middleman rubber stamping the machine's optimal blueprint. They aren't exploring tactical philosophy, they are receiving direct instructions from a vastly superior analytical engine.
But that bridge analogy falls into the exact same trap as the chess analogy. It ignores the fundamental difference between concrete and human muscle.
The physics still apply.
Concrete behaves predictably. A bridge doesn't have a bad day. A bridge doesn't miscommunicate with the column next to it because 80,000 fans are screaming at it.
Well, obviously.
The generative adjustments, you're talking about tweaking a player's velocity in a digital model to bump up a shot probability, those are entirely theoretical. The execution of that velocity on the pitch is fully dependent on the human element.
But the AI accounts for player capabilities in the tracking data.
The AI can process the graph and say, if player A runs at 8 meters per second to this exact spatial coordinate, the shot probability increases by 15%. But player A is not a digital dot on a screen. Player A is a human being.
So the coach steps in.
Exactly. The coach has to look at that mathematically perfect recommendation and apply the biological filter. They have to ask, can player A actually accelerate to 8 meters per second today against this specific defender in the 85th minute while it's pouring rain?
And if they can't?
If the answer is no, the coach discards the AI's perfect math and selects a different, mathematically inferior but practically executable tactic. The AI proposes the ideal. The human disposes based on reality.
You're treating the AI as if it's static, as if it generates one impossible, idealistic scenario and then just gives up if the humans can't execute it.
It provides the mathematically optimal choice.
But the true power of the generative component is that it dynamically offers alternative setups. If the coach knows player A can't make that run because of fatigue, the system instantly recalculates the entire web of edges and nodes to find the optimal graph for the players who can execute.
But the coach is still the one telling it to recalculate.
The AI does the adjusting. The coach is just feeding it constraints. Player A is tired, recalculate. That isn't tactical planning by the coach. That is simple data entry.
I think you're minimizing the coach's role there.
I'm just looking at the workflow, the actual heavy lifting, identifying the hidden spatial patterns, finding the geometric exploit, designing the specific countermove. All of that is entirely algorithmic.
The tactical design is.
Right. The core of modern football strategy is identifying subtle patterns in rival teams and developing effective responses. Tactic AI does exactly that by analyzing raw spatio-temporal tracking data to uncover relationships that are entirely invisible to the naked eye.
The latent space.
Exactly. We talked about high-dimensional latent space earlier. To put it simply, the AI maps the game in dimensions we literally can't perceive. Human vision simply cannot process that level of complexity.
I certainly don't disagree that human vision can't process high-dimensional latent space. Tools like geometric deep learning are undeniably revolutionary for finding data-driven insights that humans would otherwise miss.
It's incredible technology.
It's an incredibly brilliant way to overcome the limited availability of gold standard tracking data. But we have to maintain a healthy respect for the boundary between a data model and physical reality.
And you think that boundary is a hard stop for the AI?
Tactic AI is successful precisely because its creators and the experts at Liverpool FC understood this exact boundary. They focused the technology on corner kicks specifically because set pieces offer coaches the most direct, measurable opportunities for interventions in a controlled state.
They started with corners, sure.
They didn't claim to have solved the chaotic, continuous flow of open play. They targeted the one isolated area of the game that most closely resembles your chessboard.
For now, but history shows us that every disruptive technology starts by conquering the closed systems before inevitably expanding into the open ones.
It's just a matter of scaling the data and processing power.
That's a philosophical assumption about the future, though, not an evidentiary fact based on where the technology actually stands today.
I think the trajectory is pretty clear.
Well, the evidence we have shows an AI assistant meticulously designed to support a human expert. It shows a tool that provides realistic, highly accurate tactical suggestions for a very specific, rigidly defined scenario.
It does that perfectly, yes.
But it does not show a machine capable of managing the holistic, dynamic, physically grueling reality of a 90-minute professional match.
The machine doesn't get tired either.
True, but the core judgment of the coach, knowing the physical limits of their players, sensing the emotional momentum of the game, understanding the psychological state of the locker room, that remains the irreplaceable core of football management. The digital tools collaborate with that judgment. They don't replace it.
Let's take a step back and look at where we stand as we draw this discussion to a close.
Sounds good.
I maintain that the introduction of graph machine learning and geometric deep learning into tactical analysis represents a fundamental paradigm shift in how sports are approached.
The data definitely supports a shift.
Yes, and when an AI can map the spatial relationships between players so effectively that domain experts at one of the world's most elite football clubs prefer its tactical setups 90% of the time over human designs, well, we've clearly crossed the threshold.
It's a powerful metric.
The ability of the machine to accurately predict first contact, calculate exact shot probabilities, and instantly generate optimized alternative setups shows that the tactical supremacy of the future belongs to algorithms, not human intuition. The machine is no longer just processing historical data, it is actively designing the strategy.
And I maintain that strategy designed in a vacuum is just theory.
Even with a 90% success rate.
Even then, as long as the execution of those tactics relies on fallible, biological human beings who are subjected to fatigue, weather, pitch conditions, and the unpredictable reactions of their opponents, true tactical planning will always demand the collaborative judgment of human experts.
Because of the biological filter.
Exactly. Tactic AI is a magnificent tool, absolutely. But its massive success rate is housed within the rigidly controlled, isolated environment of corner kicks.
The closed system.
Right. It acts as a generative recommendation system, a brilliant assistant that allows coaches to explore options. But the coach must ultimately be the one to synthesize those mathematical probabilities with the biological and psychological realities of their squad. The human element is the necessary filter.
Regardless of where we draw the line between collaboration and replacement, we certainly agree that AI will undeniably shape the future of high-level sports analysis.
Without a doubt.
The application of geometric deep learning to solve the problem of limited tracking data by natively utilizing the pitch's symmetries is a massive leap forward for the field.
Absolutely. The data efficiency achieved by practically folding the pitch in half mathematically is remarkable.
It's genius, really.
It opens the door to insights that were previously impossible to quantify or visualize. It is a massive step forward for sports analytics and how we understand the geometry of the game.
Indeed, it is. There is tremendous value in considering both perspectives: the pristine mathematical perfection achievable by algorithms and the messy, dynamic reality of human competition.
It's a fascinating intersection.
We highly encourage listeners to look deeper into the underlying data structures of sports analytics, like graph machine learning, because as we've explored today, that perfect mathematical chessboard isn't entirely separate from the mud of the pitch. The two are becoming increasingly intertwined, mapping every chaotic movement in real time.
It certainly makes you wonder, as you watch a game this weekend, how much of the chaos on the pitch is truly random, and how much is just waiting for the right algorithm to finally make sense of it.
A fascinating thought to end on. Thank you for joining us.